Today I'm going to talk about rotation matrices, and I'm going to derive them in two different ways. It's going to be a two-dimensional rotation matrix, and I'm going to essentially rotate a vector xy with an angle of alpha. This is the x-axis and this is the y-axis. So the first method will be based on trigonometric formulas, the second method will be based on Euler's equation, and I'm going to do that in the complex plane. But let's start with this one. It's a vector with length 1, which I'm going to rotate with an angle phi. And I will end up at x-accent, y-accent. Yeah? So how does that work? We're going to calculate xy accents. And we're going to say, okay, what is the x-accent coordinate? That's essentially cosine alpha plus phi. And the y is essentially sine alpha plus phi. Yeah? X and y is cosine alpha, sine alpha. And we need this later. Yeah? So the normal xy, where you start, the starting vector will be cosine, this piece, alpha, and sine, this piece, alpha. So let's start working out the first one. So we go to x accent, y accent, and we're going to use trigonometric formulas, which will give us cosine alpha cosine phi minus sine alpha sine phi, comma, now we go to the second one and work that out using those trigonometric formulas, which by the way I explained in one of my previous videos, plus cosine alpha sine phi. Now we're going to substitute cosine alpha and sine alpha for x and y, because x equals cosine alpha and y equals sine alpha. So here we get x cosine phi minus y sine phi, comma, y cosine phi plus x sine phi. Yeah. So now we see that x-accent, the new coordinates after rotation, will be this, and the new coordinate y-accent after rotation will be that. This we're going to rewrite and put it in matrix form. So we do x and y-accent, we create a two-row matrix, call that x-accent, and we're going to work out what the matrix should be. And we can read it off from here, right? We can say, okay, that's then cosine phi minus sine phi, right? That gives you x cosine phi minus y sine phi, which is exactly the first term. And the second term is sine phi cosine phi, to give you x sine phi, right, plus y cosine phi. This we're going to call the rotation matrix, and this is what we're going to call big X. So that gives you x-accent equals rotation matrix times x. Yeah, and that's essentially the rotation of a two-dimensional vector x rotated over an angle phi. Yeah, and then you get your x-accent. Now we're going to do the same, but we're going to do it in the complex domain. So again, I'm going to do a little picture to get ourselves acquainted with the situation. Now we're in the complex plane, so it's IY. Again, we have a vector, same vector with length 1. Yeah, XIY, for instance, and that one will be rotated again over an angle phi. That remains length 1, and now we get x-accent, y accent, because it's in a complex plane. What will give you that? Well, x-accent plus y accent, this vector here, is essentially the original vector rotated over an angle phi. And we know from Euler's formula that this is essentially a rotation around an angle phi. So the only thing we have to do is work out this formula. So we get x plus iy cosine phi plus I sine phi. Work this out, so you get x cosine phi plus I x sine phi plus I y cosine phi, this times this, minus I squared equals minus 1 y sine phi. Now we're going to add the real and complex values and bunch them together. So we get x cosine phi minus y sine phi plus I, and then you get y. Oh, I made a mistake here. Oh, no. Y cosine phi plus x sine phi. There. Right? And now we can compare reals and complex values and immediately put it into a matrix like we did before. So we get x, y accent, big matrix, equals rotation matrix times x, y. And we're going to compare real and imaginary values. X accent is that, and we see that that's exactly the same as what we had before. And also for y. So we get sine phi here, cosine phi there. And again, we get a nice rotation matrix that is exactly the same as what we had before. And you see that this methodology using Euler, you don't have to remember trigonometric formulas. It makes it quite a bit easier. I think this is a good place to stop. If you like this video, please like and subscribe, and I'll see you next time.